Hi guys. Welcome to our fortnightly JetBrains meetup. So we plan this meetup on like topics focused on .NET. So we have two amazing sessions coming up today. One is full stack web development by Floyd Hilton, who's going to be presenting right now. So let me just quickly go ahead and bring Floyd so that we can get started. Hi, Floyd.
Hello.
Yeah. So how are you doing, Floyd?
I'm doing great today. How are you?
I'm good. So I think there's a bit of lag.
Yeah, it looks like there is now that we started streaming. There's a little bit of lag, so we'll just have to try and wait between those two things.
Sure. So I'll just go remove myself from the screen, so you can quickly give an introduction about yourself and the subject you're going to be presenting today.
Yeah, sure. So I'm just going to share my screen. There. So, all right. Well, welcome everybody to Full Stack Development with JetBrains Rider. I've been using JetBrains Rider since 2017 full-time, and I love getting the opportunity to talk about it because I think it's just a great development environment. I think it helps make me more productive, and I want others to give it a try. So why do I use Rider? Initially, I was having some performance issues with Visual Studio plus ReSharper. It was a little slower than I liked. And I thought, well, I'll just give this Rider thing a try. And as soon as I tried it and got using some of the features that I'm going to show you today, I didn't look back. I thought it was a really great tool. If you're already paying for ReSharper, then I think it's really affordable to move to Rider. And it's cross-platform. So I do some work on Mac and Linux as well. And it's just really great to be able to use Rider everywhere and not have to change tools just because I'm changing the computer that I'm using. So today we're going to kind of look at things with the lens of full stack development, which is something I think Rider really excels at. We're going to work right from the source control integration all the way through backend, front end, and talk about some testing and some cross-cutting features. So with that, let's see if we can get started. So here is the JetBrains Rider IDE. And I'm going to be going through a basic full stack web application that is a .NET Core Web API with an Angular and Ionic front end. And it's also based on SQL Server, which you'll see a little bit about in a few minutes. So let's see. So starting off, the first thing you need when you need to do full stack development is you need source control integration. So Rider's source control integration is really good. I've used a few other tools in the past, and I find that I really don't have to leave Rider to work with Git. It's a really good integration. So let's go through some of the features real quick. The first thing is you need to be able to get a hold of your source code. So Rider has a really great integration for working with GitHub, working with Visual Studio DevOps, or just plain old any repository URL. When you clone, it'll pull the code down and then open Rider up right into the solution or the application, which is really nice. If you want to, I use it often with GitHub. You have a sample you want to try out or see how something works. It's really easy to just quickly pull it down and start working with the code right away. Once you have your code pulled down, down at the bottom here, there you can bring up the tab that shows the Git integration. It's fairly standard, but there's a couple features that I think kind of stand out. The standard stuff, you've got your branches, you've got your history, you've also got this nice path of your history, which a lot of tools have now, but Rider has it too. It's really great to see how branches come together and merge. When you click on something in the history, you can see all your changes to the right, which is it's great. You can just work your way through and see what might have happened. If you click on a particular change, it opens the Rider diff window, which is great. It shows your changes, your additions and subtractions. It can do both side by side and unified, so you can whichever way. Sometimes one works better than the other. I'm going to look a little bit more at this when we go to commit changes, but just starting off, this is the diff viewer and kind of what it looks like. So down in here, one of the features that I really like is that you can search. So you can quickly search your history by just typing. It's really fast. It's great for when you're trying to figure out something that happened in the past. Maybe you're looking for an item number. Maybe you're looking for just something that you mentioned, so you can go back and see how you made a change. That search works really well. Another neat feature that I like in Rider is that with your branches, you can select any particular branch to only show in the view, but you can also do multiple branches. So we can do, you can type, it auto completes. You can look at 2 branches at the same time. You hit Control Enter, and it filters everything that you see down to those branches, which is again great for the type of thing that I do a lot, which is figuring out what happened. If you can narrow your lens down using these search features, it makes it a lot easier. Going along with that is another feature that's called paths. This lets you focus down on a particular area of your repository. So I can hit select folders, and it shows me all the folders within my repository. So if I wanted to say I only want to see changes that happened in my tests, I can select the test integration and show only the changes that happen in there. Just another handy feature. Let's see if there's anything else I wanted to show. I think that's pretty much it for there. Now we'll move into how the source control integration works within editing a file. So I'm going to hit Control T. You can see right here the thing, search everywhere, Control T. I'll show more about this a little bit later too, but you can type in anything and it'll find it all over Rider, whether it's in the code, whether it's in the menus, that sort of thing. It's really handy. So once you're within the code, at the top of like a method, you can see who made the latest changes. You can also click on that, and it will show you what change was made and a nice history. A thing I use a lot is the annotation, or the blame, sometimes it's called. You can right-click on the side here and hit Annotate. It'll show you all the changes right there really quickly. You can hover over it. It'll show you the message of the commit. You can right-click on it and show diff. And again, like we saw the viewer before, it opens this diff viewer that lets you see all the changes that were made, which is pretty handy. Now we can close these annotations the same way we opened them. If I make a couple of changes to this file and comment something out and save it, the next thing you do with source control is you want to commit your changes. So they have a commit tab over here at the left. It shows all the files that were changed. It'll also, if there are new files, it will show those. And each one, when you click on it, it shows you, again, the familiar diff tool, but this time it has more options in it. So this time it shows that I added a couple lines here, and it shows that I commented this code out. So within here, you can revert just single changes by clicking on these double arrows, or you can select only certain things to commit. And this is awesome if you've made a bunch of changes and you really want to do some atomic commits and only commit changes that are similar to each other, then this checkbox is great. I use it all the time to go through here. Also, when you're going through reviewing your changes, it's nice. You can actually make changes right over here. So a lot of times I'll be looking through my changes to commit them and see that I forgot to remove a comment, or I have an extra new line somewhere, and I can just go through and look at my changes and quickly just clean them up and make them better. Once you've decided what you want to commit, you come back over to the left and you can put your commit message. But there's a couple features over here, and make this bigger, that I like a lot. One is this history. You can see all of your commit messages that you put in before. And if you might be committing, you might have done a commit and realized you left out a file. You can quickly go back and grab the same commit message. You might want to look back at, oh, what was that item number I was working with? You can just look through there quickly. It's just a neat feature. The one thing about Rider is these little features are all over the place, and they just combine together to make a better experience when you're doing your development. Another neat thing here is the integration with Visual Studio DevOps. So I think this is an extension, but if I'm working in a DevOps project, I can easily find the items I'm working with in here, and then it'll add them to the commit message, so that way your changes are all linked to the item you're working on, and it makes everything a lot cleaner. Okay, so that's most of the version control features that I wanted to show. I'm going to revert these changes here, so those go away, and then close a few things. So the next integration I want to show is for the Node Package Manager. So this is mostly used in the front-end world for bringing in packages for JavaScript. But it can also be used to run commands. They call them scripts. And what's nice about Rider is you can have multiple package.json files, they call it. That's the file that's used to show the packages that are used for Node Package Manager. You can have more than one in your project, and it works just fine. In this project, I'm actually using one for my front end, and I have one for my database side, so that I can run Docker easily, because this project, the backend database, runs in a Docker container, and it's super easy to just quickly access my NPM scripts and open them. From within here, not only can you run your scripts, but you can easily right-click and jump to source, and it'll show you the package file and everything in it. It'll also, here you can see the scripts area that I was talking about. Those are the scripts that are shown on the left, and in this case, it calls a Docker compose command. So just a simple thing, but it's really handy, and I use it all the time. So now we're going to just run this npm command and bring up the local database, because the next thing we're going to look at is the database integration in Rider. All right, so we'll let that keep going, and then close that down. On the right side is where I have it configured. You can move these menus all over the place, but I have it on the right side, is the database tab. The Rider has lots of integration for different data sources. I'm using SQL Server for this one, but as you can see, there's lots of others. I've used a lot of database tools, from the Microsoft tools to plugins to all kinds of stuff, and Rider is my favorite tool. And I believe it's available as a separate tool called DataGrip. If you're just using databases, you can get it separately, but it's a really great tool. Here I have it connected to my local SQL database. One thing to note on this is it caches all the information about the database, so it's really fast. One thing about that is to keep in mind is that sometimes it might get out of date with your database, so it's always a good idea to right-click and refresh the cache when you're working in here, because you might have a table that was there and not. And as you saw, just a table, I think if you were watching, a table just went away because I had added one in my testing and removed it from the database, but it was still in the cache. So something that can trip people up sometimes. Another thing that tripped me up when I was starting with this is that you can filter what databases are shown for your particular server by clicking on this number. So there's 2 of 13 are being shown here. I'm showing the schema DBO and sys, but I'm not showing any of these other schemas. Same thing up here as you filter out. You can filter out your data sources or your databases. When you first start, they might not be selected, and you might not see anything here and think it's not working, but you just have to select that and filter. And once you know about it, it's actually pretty handy to be able to scope it down and not show too much information. So from within here, it's fairly standard. And you can see your tables, store procedures, functions, and look at all the details about them. A nice feature in Rider is the ability to show a diagram of your database. This is super handy if you're working with an unfamiliar data model, or you want to learn more about how the relationships of the data work. You can make some quick changes in here to show only the IDs or all the fields. So if you have a ton of tables, this is nice for filtering it down. Also, it's tough. It's not as obvious in this tiny database, but they have a lot of layout options that you can use. So depending on the way your database is laid out, there may be some other layout that makes a lot more sense in how to show your data. So it's nice that it has these options, and you can print it, you can export it. So yeah, it's a neat little feature. The next thing that you might want to do from within here is actually work with your database. So for the database integration, there's this idea of a console. The console is the code. It's saved as part of the project. You can have as many as you want. You can make them different for different reasons. Excuse me. So from within here, you have some really nice features. So you can have, if you have a bunch here already out, but if you type SEL and hit tab, it'll quickly show you. See if this will move up my screen. Oh, there we go. I can scroll it. So it'll show you what you can select from, and it'll show you all kinds of information about your database. And I got a connection failed to my database, so I'm gonna have to look at that before we try running this thing. I might have had a problem with bringing up my database, but we'll keep moving and see how it goes. But from within here is really nice because you can quickly scroll through all of your tables, see information about them, and you can hit tab, and it'll pick it for you. From up here, you can hit Control Space, see all your fields, and easily select them as you're going through your fields. Again, more information shows to the right. It's just kind of this nice lens into how everything works in your database. If you see if we can even run a query, I may have to go see. Oh, it's working, I guess. I'm not sure what that was about. Well, that's good. That'll make the demo better. So as you run your code, your scripts, you can see your results show up down here. There's a couple features I'll show. You can sort, filter, do all kinds of things in here. You can export this data. But one thing that's really neat is if I select, I'll show you, I didn't really talk about this. If I hit Control Enter, I can pick what I want to run, which is cool. So if I have a big query with a subquery and I hit Control Enter, I can run just the subquery, or I can run the whole query. It's pretty flexible that way. So I'm just going to run this one. So I've got, I also have this set up to open a new tab for every query that I run. You can change that, but that's how I like to do it. Now I'm going to run it again with a different set of data, just to kind of show that this neat feature that you can use. You can compare any result set to any other result set and show the diffs for those. So I'm in 10. I can compare that to 9. It opens up this nice diff here. Now you can do this not only within the same database, but if you have multiple data sources, if you're looking at a production data source and a development data source, you can run a query in each, and you can compare the results for those. inside here, you can set the tolerance level that tells you what means these rows are different. So at this point, it's saying, it's all blue. It says these are different. These are different. It would highlight them in the list. If I had a lot of data, it would show if one was added and one was deleted. But I can increase the tolerance to say, well, if 4 things are different, this row may still be the same, but show me what's different about it. And this is really powerful because here you can see exactly which fields are different in these 2 data sets. And depending on what you're working on, you might not, this may or may not be a neat thing for you, but for me, if I need to look at what might have changed, if I'm going back to look into a problem and I might need to see what might have changed in some data set, this is a super handy feature. Let's see. So the next thing, the integration with the database also, there's some other nice features. You can easily create tables within the database, and depending on what you like to do or how you like to go about it, we can do, I don't know, route photos. You can see down here as I type, it's creating the SQL script for me. I can add an ID column. I can make it my primary key, and all this stuff gets added here. Now we can just copy we can hit Control-All and just copy this. We can execute it in the database. We can run it to a script. There's lots of things you can do. If I execute it, then we'll see it show up in the database. I think I clicked execute twice, so we'll see what happens. It's going to refresh. I might have broken something when I clicked that twice, but oh, there we go. Okay, so here's our new table. So there it is in the database. Now it's there, but moving forward, what if I want to, how do I get that to where I want it to be? In this project, I have something called dbup set up that I script my changes, and then when we go to deploy in production, those changes get applied to the database. So in order to do that, I need to get a script of the table. To do that, we can easily right-click on any object in here, and we can generate the script for it from here. And then we can easily move that script into where we want to use it. Also, along the same lines, you can export data the same way. So if I have, say, I added some test data to this database or some new lookup information, you can click export, and you can decide how you want to export. Sometimes you might want something comma separated in a file, or you can do, a lot of times I'll do inserts because that's the patterns that I'm using. And you can easily just export this out, put it as part of your build deployment process, and then have the data available when you need it. All right, so let's see, I'm going to close that down. So, okay, so the next thing I want to show is just some more cross-cutting things about the navigation in Rider. So Rider has a solution explorer, and similar to what you see in Visual Studio, but some of the nice features in here is you can show all files, so you can quickly see everything, not just what's in the solution. And another way to do that, there's also this file system explorer. So sometimes if you're working, especially in a front-end project, there is no solution, there is no project, but you can still work with all your tools and everything by just showing the files in that way. Another thing that's nice in here is this assembly viewer. You can pick an assembly. I use embedded resources in assemblies for test cases sometimes, and if you use the assembly viewer, you can open and compile assembly and see what resources are in there, see more information about it. So depending on what you're doing, that can be pretty handy. Another feature in here that I really like is no matter where you are, you can right-click and say Show and Explore. So in some IDs, it depends on what you're clicking on, if you can do that or not, but this you can do it all over the place. Another great feature is Copy Path. So if I'm on a particular file, I can copy the path, and it'll give me these options. I can do an absolute, I can do a relative from the repository root. So if you need to reference a file within your code, you can quickly just right-click on it and get that. So I think that's really handy. The consoles for the database that we talked about are also all listed in here. So you can rename these, you can add more. If I had more data sources here, they would show here as well. So that's a pretty neat feature too. You can also do something in here. You can start typing, and it will highlight and move your way through the code, which is neat. But one thing I think it should do better is it only looks at what's visible. I would like it to be recursive through the folders this way. I think that would be kind of a neat feature. So, all right, let's see. So the next thing we'll go through, I want to talk a little bit more about this Control-T window. So not only can you find files in here or classes, but you also find database tables. If your database has been indexed, you can find the database. You can find, you can also find actions. So if I want to enter presentation mode, I can type presentation mode and quickly move around in here. So yeah, so you can just kind of search around anywhere in here and use this all window. I just basically use it all the time just to move around. So I'm going to open a backend file now, so we can go through a couple of things in here to talk about things that I like in here. So the first thing is at the top, you have these really nice breadcrumbs that show where the file is in your solution. So as you're navigating around, you can quickly tell where you are. And then on the bottom, same idea, except part of your namespace and your class and your method shows down at the bottom. So that's just really handy when you're moving around in a big code base and you want to see, well, where am I? I forget, and you can look and go through the different breadcrumbs. Something in here that I think somebody else might talk about today is refactoring, so I won't go much into that, but you can refactor out sections of code into new methods, which is great. One thing that I use fairly often is I can right-click refactor and change a signature. And what this allows you to do is add more, I can add a string, new variable, and then it will modify the signature. But what the neat part is, this part right here, I can, if I modify my signature, obviously all the calls to that method need to be modified. You can not do anything, but you can also make changes or even add a value in there. So recently I made a change to a signature where I wanted most areas, there were a lot of calls to that, and most of them I just wanted to add a new method to say new this to pass in. Some of them I didn't. I was able to use this to make the change in just a couple seconds instead of having to go through to every method call and fix it and find all the problems. So that's a really neat refactor feature that I used recently that I think is cool. But all the ReSharper stuff that you normally think about is all in here, and you can use it just the same way. Let's see. Okay, so the next thing I think is really cool is if we go to if we type controller in here, you can see that it also doesn't search just from the beginning of the name. It'll find it anywhere, which is really nice. And then inside the controller, so waypoint controller is my code that I wrote for this, but controller base is not. Well, in Rider, if you don't have the source code, if it's not your source code, you can still hit F12, and it'll download the symbols for that external code. This is awesome because how often do you have a base class or a method or a library that you're working with, and you just kind of need to know what it's doing so that you can work it better with your code? Well, in here, I've gotten so used to this that when I go to another tool, and I can't do it, it's really like, well, I forget how much I love that. So, that's really cool. Let's see what else we've got here. Oh, so here's another feature that I think is just a killer one in Rider. If you hit Control-Shift-F for Find All, you can search within. This is like find in everything. So you can search within your solution project directory for a search term. You can do it by regular expression. You can do it in lots of different ways. What's really great about it is after you've done your search, make this a little bit bigger, you can see that, let's see, make it a little smaller. So you can see what files you found it with on the right, and if it's more than one in a single file, it grays out the rest. So you can kind of quickly key on that. As you work your way through, you can see the code quickly down below. You saw how fast it is. Even with bigger projects, this is just as fast. You can quickly work your way through here. You can actually make changes down here as you're working. So it's just like you can stay right in this one spot. Another neat feature part of this, if I hit Control-Shift-H for replace, and I do a regular expression replacement. Let's see, I need to put parentheses around this expression. So yeah, so I kind of was working on this before, so you see that it's already in here. But with regular expressions, you'd use $1 for your first match, and then you can modify from there with your replace. Well, down here, as you're working your way through what you want to replace, it shows you what it's actually going to replace. And this is really great. I mean, here's a super simple example, but regular expressions can get pretty complicated. And when you're trying to do a find and replace all over the place, maybe it's really great to just see, oh, this is exactly what it's going to put in here if I say replace. So it's just that. So once you're in here, if you want to keep working with this find set, you can say open in find window at the bottom, and it will open. It's searching for me. There we go. It will open the results in the find window. Yeah, here we go. So it looks funny because I have this zoomed in so much for this presentation, but let me see if I can make it a little clearer. Basically, it'll open it up down in this find window, and then in this window you still have tons of options for showing what class it's in, whether it's a read or a write. It's you can navigate all over the place from here. Let's see. So now let's look at a little bit of front end stuff. I'm going to Control-T again, and I'm going to open up a TypeScript file. So this is an Angular type component, and this is basically can be used like a custom tag in HTML. So this is a component that you can put in your HTML, and it will show something. And when you're working with this in Rider, what's really cool, and I haven't seen this a lot of other places, this selector is what shows in the HTML file to make this component show up. And if I'm working in here and I say, well, I wonder where this is used, I can hit F12, and it'll search not only in the TypeScript code, but it searches in the HTML as well. So if I click on this, I can see, oh, look, this is used right here. It's a small thing, but it's just another super useful thing for when working in Angular that in other editors that people use for Angular all the time, I haven't seen that work. Also, when working with TypeScript and Angular, in this case, it will look at all your definition files, and you get nice IntelliSense. So if I want to add another interface here, I can quickly find it, and it'll show me on the right everything about it if it's included in the definition. So that's just great. Oh, if I do that, if I do this, you get help that says, oh, you're implementing an interface and you don't have all the members, so I can easily include the members and make everything work correctly. So that's good. Let's get rid of that. Let's see. So moving along with this, the next thing is, so this is a TypeScript file, though the TypeScript integration in Rider is really good. It doesn't, what's nice about it is it doesn't hide anything from you. You can see, so down here at the bottom I have my TypeScript. I can see what version is it being run. I can look at the console to see what's going on. Let's see. If I look in here, I can see settings for my TypeScript. Let's see. Yeah, right here. So I can easily just see what version's being used, where it's being used from. In this case, it's a node module. And you have good, some nice options here for how to work with your TypeScript. I bring this up just because other times with other systems, it's more hidden and it's hard to tell what's really going on. But in here, you really can quickly figure out what's going on. While I'm in here, this is the settings area. This is really great because you can quickly search in here. I don't know, color maybe. So you can look for like the color scheme for your current, what you're working with. You could quickly make changes in here to your color scheme. You can basically do anything, but the search is awesome because look at all the settings, right? How do you ever find anything? It's either Googling it or it's using these search filters. Okay, so that's how the TypeScript integration works. So that's just a few features, back end, front end. Now let's show, I'll show you how the debugging works. Next, Rider has a great integration for debugging for both the back end and the front end. And so the way that works is you've got these debug configurations. In here, you can add a new configuration for about anything that you can think of to debug or run. In our case, I'm running the back end. I'm debugging the back end. There's .NET Core, just a .NET Core executable. And then the front end, I'm debugging with Chrome. So I'm launching a Chrome browser in debug mode and attaching the debugger to that. The way that we run these is you pick what you want to run and you hit debug. And that will build a code and attach the debugger. So that was the back end. Now we're going to use that Node Package Manager to start our Angular front end web server. And once that's up and running, we can, we'll wait for that to get going. It'll just take a second. Once that's up and running, then we can launch Chrome in debug mode, and we should be able to do some debugging. Okay, so now I just choose that I want to debug my Chrome Angular application. Get that up and running. Okay, and then I'm going to take an action here. And then, so here's a breakpoint. So nothing stellar to show here other than the debugging works really well. Same stuff you're usually used to be able to see everything that's happening. If you hit F11, you can step in just like normal. You've got your list down here of every of your different steps that you've taken. If you go back, you can see what all the variables were everywhere that you've gone. So it's nice for stepping through and seeing everything that's happened. So I'm just going to continue with this one. Another thing that's another one of those nice little touches is if you do conditional breakpoints, you can basically say only hit this breakpoint if this condition is met. then you can do it in here. But what's nice is they added this history window. It's short in this project, but it'll bring up a history of all the different breakpoints, conditional breakpoints that you've used. So instead of having to type this equals this for the kind of 100th time, it's right here, and you can easily select it. So that's a nice feature for the debugging. So that was the kind of back-end debugging. Same thing. I just took another action in the application, and now we're in. Now that we're in a TypeScript file, and same thing. We have access to all the variables, everything that's going on. You have your console, which is the same console you'd see in Chrome if you were debugging in Chrome. Same thing here too. You can step through all your changes. So very capable debugging to work with your full stack application. All right, so now we're going to, I'll let that continue, and then I'm going to stop the debugging session, and I want to leave the database running, but you can see how up here it shows everything that is being debugged right now. So I can easily stop the things that I want to stop, leave the database running. And the next thing we're going to look at is testing. So let's see, let's make sure how I'm doing on time here. Doing okay. Let's see. Where? Okay, so the next thing we're going to talk about is testing. So let me close all of this stuff and this. And down at the bottom, we have our testing session. You can see if the tests pass or if they fail. Let's see. You can see that the change. Let me roll back this change. There. Okay. So you can see if they passed, if they failed. If they fail, you can see the exceptions that happened. There, you can double click on them and see the tests that you can run. In here, what's a really nice feature is that they have this menu here to the left. So if you're working on a test right here, you can quickly and easily just run or debug your test, set breakpoints, that sort of thing. Another thing in testing that's nice is if you debug out to the right line to the console, within the test results, you'll see to the right here, you can actually see the debug trace. So it's really easy to just see the changes that you've made and know that easily debug what's going on with your tests. So let's see. I'm just going to do a quick check on the time. Looks like it's been about 40 minutes. I'll show a couple more things, and then we'll move on to some questions, I think. One area that I think is kind of neat, that's just a neat thing, is the favorites area. So you can create different favorites areas in the IDE. Sometimes in an application, everything's built in layers, and it's hard to find how everything goes together. So if that's the case, I like to create a favorite in here with all the different pieces in the part of the whole stack, like a vertical slice. So I'd have my back end and my front end all here so that I can quickly move through. I might have web pages in here so I can get through to those. That's just a really neat feature that I use a lot. And the last thing I guess I'll mention is the window management. So you probably noticed when I was going around here, but these windows stay open when you open them, and then you close them if you want to close them. In Visual Studio, when you click and it opens over your code, and then you have to kind of click somewhere else for it to close, I find that a little bit harder to use for me personally. So the window management in Rider, I think, is just really slick. So yeah, so I think I'm going to stop my screen sharing now and then see if there's any questions.
Hey, Floyd.
Now that I stopped my screen share, I need to find the window that shows you guys.
Okay.
There we go.
Yeah. So yeah, great session, Floyd. I'm sure it was like it's very lovely. So let me just quickly ask the audience if they have any questions. So guys, if you have any questions, please enter them in the comments box so that I can show them to Floyd and he can answer them live. Okay, so looks like there aren't any questions. Yeah. So yeah, somebody's commented really great session by Floyd by Nitesh. Yeah. So yeah. Okay, so we have a question.
Favorite tip. Let's see. My favorite tip or feature I kind of already showed is the search is the find in files. So the find everywhere feature. I just use it fairly often, especially moving into uncommon code bases. The ability to navigate around is just the best. So that's the feature that I probably use the most.
Okay, we have one more question by Nitesh.
So in the code area, you can in the Git area, you can do rebases. You can do merges and all of that. So if you want to use the Git integration for that, you can. Yep.
Okay, then so there are no more questions. I'll just go ahead and close this session. Yeah. So yeah, thanks, Floyd. So thank you a lot for coming on to this webinar and for sharing your knowledge with the community. It was great having you here, and hope we can collaborate again on another webinar soon.
Sounds great. Well, thanks for having me, and have a great rest of your day.
Sure, Floyd. See you.
Yep.
Yeah. So that was Floyd, guys. He was joining us from the United States. So coming up next, we have Ganesh. He'll be speaking about refactoring code smells with Rider. Without further ado, let me just go ahead and bring Ganesh onto the screen. It looks like you're on mute.
Oh yeah. Oh yeah, thank you, Akshay, and hi there.
So I'll just go backstage so that you can introduce yourself and session you're going to be speaking about.
Sure. Okay. Hi guys, I'm Ganesh, co-founder of Codox Technologies. Thrilled to be here to share about some of the very interesting tips and techniques, and also how, in the form of how do we identify smells and refactor the existing code with Rider and ReSharper. So I will stop this camera and share my screen. All right, here we go. I hope you're able to see my screen. Okay, great. So in this session, I'm going to cover how do we identify smells automatically, and how do we refactor it. And identifying smells and refactoring them automatically can make you really productive. So refactoring is all about clean code. It's quite common to see very bad and smelly code. Identifying the bad smells in code and transforming the code could make the quality of the code really better. So from the smelly code to quality code is what refactoring is all about. So in this session, I'm going to talk about how do we automate most of the refactoring tasks. Take simple example like renaming a variable. So if we do it manually, we may forget to update some of the variable names and it will result in errors. So it's error prone if you do it manually. Also, it takes more effort to find all the places where a method or a variable is used and then refactor it. So the best way to refactor would be to, or rename would be to use the IDE and do the refactoring. So ReSharper and Rider automatically identifies the smells in the code, right? Also, if you just click on any code segment and choose refactor this, you will have options that's thrown up for you to think about the possibilities of how the existing code can be transformed or improved. So you can refactor your code by choosing the refactor menu option in Rider, or refactor this option with invoking Shift Command and R, or click the yellow bulb button, right? So invoking the context action by Alt Enter is one of the easiest things to do. And before jumping into refactoring, let's see how not to refactor. If you have a smelly code, hiding it under is not the right way to refactor. So let's go further and see how Rider makes and ReSharper makes our life easy as developers in doing refactoring. Let's start with a simple example, extracting a method. Large methods are one of the biggest enemies for readability. It's easy to end up with excessively long methods with hundreds of lines of code. The rule of thumb is that if you're able to see the entire method within your screen, then it's a good method. However, like trying to zoom in and reducing the font size, etc., are not the ones that I mean by identifying if the method is very big or not, right? So that's putting it under the rug and trying to figure out to deal with the long method. Ideally, a method should read like steps. So we should be able to extract code segments from the existing methods. And one of the interesting tips is to look at the new lines or white spaces or the new lines between or the block separators. And each of those block separators indicate that there's logically a method that could be extracted. Let's see an example. So here is an example where we have a main method where data is read from an Excel sheet, right? Now, this is a roundabout way for invoking the refactoring. You can directly choose Shift Command and R, and we can do this refactoring and give a name, and the method gets refactored, right? And so on. So you can look at the steps, right? And the steps are often indicated in the comments, and you could see the blocks of codes, right? So when we have such blocks of codes, which indicates that these are candidates for refactoring. So we can give meaningful names by selecting those blocks of code and then do the refactoring. So let's do one more refactoring by extracting a method. So yeah. So now the original method got broken it up into 3 methods, and the original method reads well. So as a method does one thing and that one thing well, and that's what we are looking for. Another simple example of improving the existing code is to check parameters in methods. So to make your code much more defensive. So we often see applications breaking easily with missing validation checks. For example, missing null checks, or checking if the collection is empty or not when it is passed as a parameter. So we can code defensively and add this validation code automatically. So just point out the parameter and click the hammer icon that appears and add these checks. So let's see this. So here we have two parameters, entries, which is a list, and we have an object called report generator. So let's add a null parameter check, and also the check for making sure that we are working on not a null argument and not an empty collection. Another simple refactoring is extracting variables from magic strings. So magic strings are hard-coded strings in the programs. Though it is extremely convenient to just embed the required strings in the program, it's a bad practice. So we can extract them to named constants. So if needed, we can extract them into resource files, especially for internationalization. So it's easy to extract variable or inline a variable with just context actions. It's very easy. So let's try this. Here is an example of HTML being generated. Ideally, we should not be dealing with such HTML code generation inline in the code. So just for an example, even if you have something like that, how do we do minimal refactoring to extract the strings, magic strings, and make meaningful variables out of that? Ideally, we should have a class, for example, that represents that abstraction of the HTML file, right? So, and we should use some libraries to generate those HTML files. But for an example's sake, we have given, I'm taking this and showing how we can do that. So inlining a variable or extracting a variable can both be done very easily. Now let's consider extracting the classes. So large static methods often indicate missing abstractions. So when you have large static methods, right, I observe that most of the time it's an indication that the method belongs to a class on its own. So the smell is a missing abstraction smell, and the refactoring is extract class refactoring. So what I'm going to show is an example, and that needs required refactoring, and just shoot those methods, large methods, and convert them into relevant abstractions. Here, for example, we have a class called air quality reporter, and we have read Excel sheet as a method. So reading an Excel sheet could be a lot of logic in it, right? In this case, for example, there are some 25 lines of code for extracting, reading from an Excel sheet. So what we could do is, as a first step towards refactoring, we can extract that method into a class on its own. In this case, I'm calling it XLS reader, and you can give any meaningful name and change the method, because on XLS reader we are saying read, and we can extract the constructors and other methods to make the abstraction complete. And this is a first step towards refactoring this XLS reading, the Excel reading, right? Okay. So another example of refactoring is constructors to factory methods. So to control object creation, we often convert the constructors to factory methods. So there are numerous contexts where we need to control object creation. Consider, for example, you want to reuse some of the objects. Let us say in a widget code, you have a lot of colors to manage. So instead of creating the color objects numerous times, repeatedly, you could create one color object representing each of them. For example, red, right? So only the red component will be full, like 255,0,0, and you can have an object holding that red value. And if red is required again, then instead of creating a new red object again, that can be reused, which is flyweight pattern, right? And another example is singleton pattern, where we are restricting the object, creation of the object to only one object. So When we want to control the object creation in these ways, for example, then we cannot do it with constructor because constructors will always get called and new objects will get created. So we can transform those constructors to factory methods. So with a publicly available constructor, you cannot constrain the object creation. So what you can do is focus your or point your cursor on the constructor, use refactor this and convert the constructor to a factory method with just a few clicks. So let's see this example. We have a class called entry and we have a constructor called entry, right? And which takes the location and pollutant reading as arguments. Now let us say we want to control the object creation and we want to extract a factory method out of it. So we can give a meaningful name like a create entry, and now we have created an entry from we have created a factory method from the constructor. Now we haven't done the benefit of doing this factory method, which is, for example, caching the entries or limiting the number of objects, etc. But this is an example to show how easy it is to create a factory method from an existing constructor. So we can transform the large parameters or parameters that are often repeated together, right, into classes on its own. So large parameter lists and data clumps are extremely common smells in large code bases. So as a rule of thumb, if there is more than 4 parameters, we need to consider refactoring. And data clumps and large parameter lists are not the same. So data clumps are something that some entities that always go together. For example, a trivial example is a rectangle, right? We have x1, y1 and x2, y2, or x comma y and then length and width. So this length and width or x and y always go together. So we have to abstract that into a point as an abstraction. So x and y will always be passed together, and that's why it's called as a data clump, right? So in other words, data clumps refer to related parameters that are always used and passed together. In other words, it indicates that it belongs to a separate abstraction. So with transform parameters refactoring, extracting data clumps to data classes is extremely easy. You can just transform your code by just clicking. So here we have again the entry class, and we have 8 parameters, which is not really good. So now let's do extract the data classes from here. The first 4 parameters is about location. So let's give the name of the parameter as location. So we have created a class name location now, and you could see that Rider has updated the fields accordingly. So now the second entry in this constructor is a pollutant entry, so our pollutant reading, and now our entry constructor is shortened simple. It has 2 parameters, which is location and pollutant entry, which is much more readable than having the data clumps, which was before, right, which was 8 parameters. Unfortunately, this refactoring is straightforward. We don't have to create those classes manually, and Rider does it for us. All right, so let's go to the next one. So interfaces to abstract classes and vice versa. So let's take an example of the world of UI widgets, right? So the base type of widget doesn't exist in the real world. So the widget abstracts various concrete widgets such as text widgets, scroll bars, grids, and so on. So the base type, if you're creating a base class out of the existing concrete widgets, then it's best to make it as an abstract class, because it's a generalization of the specific components or widgets that are out there. And it is not proper to make that as a widget as an interface. So let's see an example of an interface. In the world of UI components, consider scrollable as an abstraction, right? Now, not all UI widgets are scrollable, like text widget or or a grid may not be scrollable, right? Now, scrollable by itself doesn't have any concrete behavior. It just provides the methods such as scroll up, scroll down, etc. So it's a protocol that the abstractions have to implement. So it's best expressed as an interface. In other words, we use interfaces when they are adjectives or optional ones, optional properties or optional features that an abstraction can have. Whereas when it comes to abstractions, we have concrete abstractions and we are generalizing the properties, generalizing the behavior of the classes and create a base type, right? So if you use them, we cannot use them interchangeably, but we could see that it often happens in the real world. So when you want to convert an abstract class to an interface and vice versa, what you need to do is just point at that and select refactor this. So in that case, this conversion becomes very easy. So this is a trivial example. Let's say you have an abstract class called expr and we have an abstract method gencode in it, right? Now what I have to do is I have to point at the expr and select refactor this, and I have to convert the abstract class to an interface, and vice versa. I can also do from, if I have an interface, I can convert the interface to an abstract class. There's nothing right and wrong here. It depends on the context. So depending on the context, if an abstraction is best expressed as a base type, you have to use an abstract class, and if an abstraction is best expressed as a protocol, we have to use an interface. So these are the smells and refactorings we have covered so far. So it's just scratching the surface. So when you have large methods, we can extract helper methods from it. And when we have unchecked methods, we can add parameter validation to those methods. So when we have magic strings, we can extract constants and variables. And when we have large static methods, one of the possible refactoring is to extract classes. And when we have constructors, we can extract or transform some of them by adding factory methods. And when you have data clumps and long parameter lists, we can extract them into data classes. When you have an inappropriate abstract class, we can consider transforming it into an interface. So this is only some of the examples. And what's interesting is almost all of this is something that is automatic. So one of the techniques that you can follow in our regular work is to refactor repeatedly for creating clean code. So often we try to achieve some functionality and write code, and often we leave it there. So when a code just works, that's often smelly, and the design is not excellent. So when we revisit that code and improve the underlying design of the code, then it becomes much more better. Now, let me take an example. Here is a code base which is about processing pollution data and creating relevant reports based on the city-wise pollution, or is it something like what kind of pollutants that we have. So here we have this content. So we have a lot of entries in this pollution entries in this Excel sheet. And what we're doing here is we are opening the Excel sheet and creating reports such as city-wise report, country-wise, pollutant-wise report, etc. Sorry, let me open this. Now, when we are writing the program to solve this problem, we end up with code that works, but that becomes smelly, right? For example, look at this code, right? Generate the PDF. So we are creating a HTML content and converting them into a PDF document and writing it to it. Now this is quite smelly because this has multiple abstractions, not being separated. The concerns are mixed up. So we have the HTML as a concern, right? And that is actually mixed up with the PDF generation as a concern, and that's also mixed up with pollutant report as a concern. So the three concerns are mixed up. So we need to extract three different abstractions from this single code base, right? And if you look at this, a lot of static methods. So if you look at this here, you have static methods. So when you have a lot of static methods, it implies that the design is not very effective. So for example, if you can see here, the lot of almost every method is a static method, right? So this is an indication of very procedural code. So the way to deal with that code is to repeatedly refactor the existing code. So so we can identify the things that requires refactoring, and and just point at it and try to do refactoring. So in that ways, it becomes much more manageable, and the code becomes maintainable. So this code can still be understandable and maintainable by developers, but think about it: if it evolves with more features, and over a couple of years, the code becomes completely unmanageable, and that's the reason why we need refactoring. For example, consider this code. So we have get the row and column count, right? So this comments indicates that these belongs to separate functionality. Even one-line methods are better because those methods indicate one single step of the functionality that we are performing. So these actually belong in methods within this abstraction. So by using a rider or any IDE, which is quite capable and powerful, we'll be able to deal with this much more effectively. So some of the examples are already covered. For example, let's say you have this hard-coded magic string. Then we can introduce a variable here. So the variable what we are dealing with here is report generation text, right? So we can have this variable itself, and we can say that report footer. So as simple as that. So doing very simple improvements like this makes a big difference in the quality of the code in the long run. So this is the code that was before, and I have used the techniques I have described so far, and I've extracted the methods here and the classes here, and almost all of this is done automatically. So the refactoring that we can do is quite powerful, and it could be very effective. For example, these are all extracted into methods, so this becomes a reusable functionality. So if you want to use HTML builder somewhere else, I can use it somewhere else, right? Because this is an abstraction. It doesn't get polluted with the PDF information, or doesn't get polluted with the R quality report related functionality. I can just move this into another package called utils, and we can reuse that. So imagine the power of such refactoring, right? And there's no such thing as perfect code, right? There's always opportunity for improvement. For example, here, so we have the hard-coded functionality. So what I can do is, whenever I find such opportunities for improvement, we can just try to automate it, and we'll say margin here. And we made one single simple improvement, and extracted a magic number into a parameter, and we did an improvement. And when we do it repeatedly, the quality becomes much better. So with that, I think I am in the end of this presentation. So you can automatically transform the code, and given the time pressures that we work in, this is a very powerful thing to do. So, yep. So the key takeaways: don't do refactoring manually. As much as possible, automate it by using relevant tools, especially powerful and rich IDEs. And you don't have to remember too many shortcuts to do such refactoring. So just using refactor menu option, or refactor this, or context actions. This three is enough, and you'll be able to refactor your code to much higher quality code. So with that, I will take any questions, and let me go back and see if there are any questions.
Yeah, so I think I have a couple of questions. So the first question is by Pranav.
So should short code fragments, duplicate ones, be refactored? So there is a balance in doing refactoring. So if it is only twice, then it's debatable if you want to refactor it. So there is a rule of thumb by Martin Fowler called rule of 3. So if something repeats 3 times, that's really worth refactoring. So if it is duplicate, for example, only 2 times, all the words that you have used duplicated once, it may not be worth refactoring because it's a short code segment. So it's a balance, and you don't have to always refactor, and you can make a prudent decision not to refactor as well, depending on the context. So yeah, that's a very nice question, Pranav. Thanks for this question.
Okay, so
I hope I answered yours.
so then I think there's one more question by Vishal. I'm just bringing it up.
Yeah. So hi Vishal. So how to refactor similar but not identical method where one method extends the functionality of the other, right? Oh, okay. So let us think about the similarity of the methods, right? There are 4 kinds of duplication. So let me share my screen again and explain the how it works. So what are the kinds of refactorings that we have? So let me increase the size and talk about types of clones. So there are 4 types of clones. So type 1 clone is exact duplication, right? So let's see example. Let's take a simple, very conventional example. For int I equal to 0, I is less than 10, I plus plus, right? And console.writeLine I, right? So of course, this is a smelly code. We are not supposed to use console.writelines in our production code. We are not supposed to use indexed for loops, right? But just for the sake of an example of explaining the types of clones and how do we deal with that, so I'm take this example. So when you have an exact duplication, so this is how it looks like, right? So when type 2 clone, so syntactically similar clones. So we have syntactically similar clones. For example, we have a for loop where the variable name is different, but syntactically they are same, right? We can conceptually, extract into a single method by extracting a parameter from here. So now, then different clones. So we can have a syntactically different clone, which does the same functionality, right? So we have this 2 loops, but one is written in a while loop. Again, I'm giving this example just for explain the difference between the clones. I'm not saying this is how you program. So we have console.writeLine and I plus plus, right? And the type 4 clone is semantic. So semantically different clones is when we have something like this, but we have the same functionality achieved in some other way. For example, for each I in range 0 to 10, assuming that we have a range method, right? And we are processing that code, right? So these are the kinds of clones that you could have in your programs. So let's try to deal with one by one. So we have exact duplication of the code. This is very straightforward because a writer itself, if I remember correctly, there is an option to find the code duplicate, and you can refactor it. And it's very easy to do when you have exact duplication. right? You have to extract it to a method, and you will be able to deal with the exact duplication. So when you have syntactically different similar clones, then what you have to do is you have to extract as parameter. So we have a method, and the parameter will take care of the difference in this in the similarity. We are able to achieve the same functionality but with slightly different ones. So when you have syntactically different clones, that requires more effort. This is where manual programming comes into picture. IDE may not be able to help you refactor this automatically. So you may have to extract a method from one of the code segments, and then you should be able to call that other method, because it's syntactically different, semantically same, right? So you should be able to make that call much more easier, right? But in this case, you have to do it manually. And when it comes to semantically different clones, it's quite interesting how to deal with it. So the functionality may be different. So you may choose not to refactor it, right? So that's what it means by semantically different clones. So you may actually choose not to refactor it. But if you see that there's a reasonable functionality that you can take out of it, then you can extract a method and try to unify this. And this requires more effort. So in other words, IDEs can effectively help here to do automated refactoring. And when it comes to type 3 and type 4, it's much more difficult to do that. And so part of this functionality can be done manually, and part of it can be done automatically. So when I say part of it, you can extract a method automatically, but when you call those methods for other scenarios, that you have to do it manually. I hope I have answered your question.
I think so too. So, like, we have one more question.
Sure. Is it good to go with interface pattern? So Tejesh, I'm not really sure if I understood what you mean by interface pattern. So if you're mentioning about using interfaces effectively, programming to an interface, yes, that's a very good thing to do. So when we have concrete behavior in the programs, right, then the code becomes very brittle. So the example that we discussed, like HTML creation, right, or PDF creation, or report generation. So these aspects, if we are writing code where the coding is embedded, the abstractions are embedded in the programming logic. In other words, HTML, for example, instead of having an abstraction called HTML report, if we have HTML tags embedded everywhere, just to give an example, right? So that HTML generation functionality cannot be reused anywhere else. So this is depending on concrete aspects. So if you want to create reusable, effective, well-designed code, so then these concerns have to be separated. So we have to program to an interface. So where the interface means the class and its methods. In this case, you have a HTML report or a PDF report, right, as classes, and the methods that it's supporting. For example, add header, add body, add paragraph, add new line, etc. So we can create that abstraction and use effective programming practices. For example, builder pattern is something very useful to deal with creation of complex objects like PDFs or HTML, etc. So in those scenarios, we can program to an interface and not to an implementation. So yes, so in general, it's a very good idea to program to an interface and not to an implementation. So depending on abstractions and avoiding to depend on concrete aspects in a program. So I hope I have answered your question, Tejesh. It's a very good question. Yeah, thank you. So
do we have like any more questions, guys, before we wrap up the session? Okay, so I think there are no more questions. Yeah, thank you, Ganesh, for your session. It was really good, and as you can see, we had a lot of good questions as well in the comments. So yeah, so by saying that, we can close up this session for today. Like, thank you all for joining us here. thank you one and all for joining us for these sessions on .NET, like focus on JetBrains, Rider, and ReSharper. We will be hosting one more soon, so we do request you to like stay tuned for our updates. Do follow our YouTube channel, which is CodeOps. You can just go and click that click the subscribe button on it. So apart from that, I think we are all good. So see you guys at the next one. Yeah, bye.